Hello viewers, greetings to you and welcome to my live stream. Please, as usual, let me know where you're watching from. This live stream is for questions and answer. If you have your question, please drop so that we can, discuss one-on-one. You have any challenge as regards solar power installation, mostly when it comes to system design, knowing the size of components that you need for your solar installation. The size of inverter, size of a battery bank, size of charge controller, size of panels, and size of cables, breakers, and other installation kits. So you're welcome to my live stream once again. Please do let me know where you're watching me from, and if you have any question, please drop your question and I will attend to them uh, as we move on. So before you start dropping your questions, many persons are asking and they are saying I should explain what an inverter is. Though I have a small inverter here, this one is a modified sine wave inverter and it is a 2000 watts inverter. So an inverter is one of the components of a solar power system, and the basic function of an inverter is to convert DC to AC. That is, when you convert this inverter to your battery bank, if you look at the inverter, this is the input side of the inverter and this is the output side of the inverter. So the input side of the inverter, we have DC. That is, you are connecting these two terminals. You can see red and black, positive and negative. So this is what you connect to the battery bank, and the inverter will now convert the DC to AC. So what you'll be having here is output DC. Last Chuku Iheanyi, thanks for joining my live broadcast. Please let me know where you're watching from. Drop your questions so that I can attend to them. So we have the pure sine wave inverter and the modified sine wave inverter. Like I said, this is a modified sine wave inverter, and it is a 2000 watts inverter, and it is also a 12 volt inverter. Now all inverters, they have what we call nominal DC input voltage. Nominal DC input voltage. Mr. Lars Chuku, you're watching me from Oshodi, Lagos State, Nigeria. Thanks for joining my live stream. I'm very grateful. So the inverter have what is called nominal DC input voltage. All inverters. So we have 12 volts inverters, 24 volt inverters, 36 volt inverters, and 48 volt inverters. We have other higher voltage like 96 volts. We have 120 volts. So the nominal system voltage or the nominal DC input voltage of inverter is what will guide you in configuring your battery bank. So if it is a 12 volt inverter, it means your battery bank must be a 12 volt battery bank. Like this one is a 12 volt inverter. You cannot connect it to a 24 volt battery bank. That 24 volt battery bank will, burn the inverter, will destroy the inverter. So you can only connect it to a 12 volt battery bank. So if you have a 12 volt battery, you just need one. But if this inverter is a 24 volts inverter, it means if you have 12 volts batteries, you need two batteries, minimum of two batteries, because you need to connect them in series to give you 24 volts. If you don't connect them in series, that 24 volt inverter will not work. So you need to, anytime you're choosing an inverter, you must look at the nominal DC input voltage of that inverter, because it is very, very, very important. It will guide you, it will help you. If you fail to connect the inverter to its required nominal DC battery bank, and that is either 12, 24, or 48-volt battery bank, that inverter will not peak. It will not function well. At times, it may end up destroying that inverter. If the voltage is higher, let's say you connect a 12-volt inverter to a 48-volt battery bank or 24-volt battery bank, it will destroy that inverter. Now, if you connect that 12-volt inverter to a 6-volt battery, the inverter will not peak because the voltage is very low. So you must know how to do these things properly so that you will not be having issues. Now, on the AC side of the inverter, depending on your country, we have 220, 230 volts, we have 110, 120 volts. So you look at the DC input side of the inverter and the AC output side of the inverter. The alternating current, is it the AC side, is it 220 volts or 110 volts? So if your appliances, they are 220 volts, it means you need an inverter that outputs 220 to 230 volts. So always take these things into consideration. And for you to choose the inverter you need, you must know the size of the total power rating of your loads. It is the total power rating of your loads that will guide you to choose the size of an inverter that will power those loads. Now, it is not good for you to oversize an inverter or undersize inverter. It is not too good. So that is the more reason why you need to properly size the inverter so that it will be able to efficiently power your loads without issues, without challenges. If failure to price an inverter that will power your loads, will make either the inverter to be tripping off, or whenever you put on your loads, the inverter will not be able to power them, will not be able to carry them. So always do well to know how to properly size these things. Please, I'm waiting for your questions. If you have any questions, please drop your question. And there's another component I want to talk about. This is the component. This is a breaker. If you watch my channel, the videos on my channel, you will see one of the videos I drop about the breaker. This is a breaker. Now, before choosing a breaker, you must know where you're going to apply it, whether it is DC side or AC side. We have DC breakers and we have AC breakers. You don't use an AC breaker for DC applications. So know where you are going to use it, and you should be able to know whether it is DC or AC. If you look at this one here, don't know if you can see it clearly. If you look at it, you will see the DC sign there. This one is a 100 amps breaker, and the maximum voltage this breaker can take is 250 volts. So the essence of a breaker is also one of the OCPDs, that is overcurrent protection device. So you install this between the solar panel and the charge controller. Between the charge controller and the battery bank, if you have a breaker. Between your battery and your inverter, this is the inverter here. Now, between your battery bank and the inverter, there should be a breaker. Then between the inverter, that is the output side, the inverter and your load, you should also have a breaker, but from here it will be AC breaker. Now, this other side, all of them will be DC breakers. So you need to know the maximum amount of current that is flowing through the circuit. You need to know also the maximum voltage. This will guide you in choosing the size of breaker that will properly fit into your system. So please let me know where you're watching from, and also drop your question if you have any question, any challenge you're having as regards solar installation. What question do you have? Let me know in the comments. Please drop your question. It is only one response that I'm seeing here. Okay, Mr. Nii Adilami, you're watching me from Abuja, Nigeria. Thanks for joining my live stream. Please, If you have questions, please drop your questions. Please drop your questions. You said you joined late. You are not too late. You can ask your question if you have any question. I was talking about an inverter, that this is an inverter. It is one of the components of a solar power system, and the basic function of an inverter is to convert DC to AC. Why do you need an inverter? The reason why we need an inverter is because what the solar panels, are generating is direct current. What is stored in your battery bank is also DC. But the loads that you have, your refrigerator, your water pump, your bulbs, your chargers, both laptop and phone charger, all of them, majority of the loads, the conventional loads we are using are AC loads. They are AC appliances. So how can we use the DC energy that is stored in the battery bank to power these AC loads? So that's where the inverter comes in. The inverter receives the DC from the battery, converts this DC to AC, so that you'll be able to power your AC loads. So that is the basic function of an inverter. And I said, for you to choose an inverter, you need to look at the nominal system voltage of that inverter, the size of the loads you want to power with that inverter, and the voltage rating of your appliances. Are they 220 volts or 110 volts? So that's what we have been discussing. Mr. Nii Adelami, please drop your questions if you have um, any question, if you have any challenge in system design, in solar system installation. Thanks once again for joining my live broadcast. Now, if you look at a solar power system, there are many persons that will be asking, can I use some will ask, can I pump water without batteries? Can I pump water without batteries? Yes, you can pump water using a solar pump or a solar pump inverter. You can connect the solar panels without the battery bank, but it will only work during the day when the sun is available. So the solar panels will drive the pump, whether it is DC pump or AC pump, and it will be able to pump water without your without batteries. But the disadvantage is that when there's no sun, those the pump will not work because there's no power supply. So most of the solar pumps, most of the pumps we are having both in rural communities, in some of our cities for public use, most of them are solar pumps. So they just connect, they only have solar panels and the pump, the pump controller, breakers, and cables and other accessories, but there's no battery bank, there's no inverter if it is a DC pump. But if it is an AC pump, you need solar pump inverter. Mr. Nii Adelemi, I am interested in knowing the difference between the all-in-one all-in-one solar generator and the conventional solar system, which is more efficient. We have all-in-one systems. In other words, they are integrated system. Everything is inside that system. Like in Nigeria, we have BB Jump. I don't know uh, if they are still operating here. We have BB Jump, we have Sun King, we have MTN, Lumos, and other solar generators. The name generator is just to generate electricity. So everything is integrated in a box. Most of them now are using lithium batteries. So they have the batteries inside the box. The what's it called? Some of them that have inverter, external inverter or internal inverter, everything is integrated with the controller. Then all you need is just to connect your solar panel to the solar generator and it will start working. But you should know that the solar generator, they are customized systems. You cannot upgrade them. They are already customized. So it's always difficult to add batteries, add panel, or increase the size of inverter. But the other conventional solar systems is that you get different solar components the inverter, the charge controller, and the rest, they are somehow bigger. And all these components, unless you have something like the hybrid inverter, the hybrid inverter has an inbuilt charge controller, either MPPT or PWM charge controller. So the charge controller is inbuilt, is integrated. But solar generators, they are good for, powering small appliances. Like you want to power your generator, sorry, you want to power your television, your decoder, and a few lighting points in your house, and probably your, charging of your phones and your laptop. So, and it is handy. You can move it easily. Probably maybe you want to relocate or you're traveling. If you want to carry it, it is more easier for you to move with it. But the other ones, the solar panels, they are bigger. So that is why you need to know how to properly size the system. So when you talk about efficiency depends on your usage. You see some advertisers, they will tell you this solar generator can power a freezer, can do this. Before you go into it, check the power rating of the inverter, check the battery bank, can it sustain. Some of them, they are just maybe 300 and something watt hour, some 200 and something watt, some 500 watt hour. So some of them, their capacity is not that big the way most advertisers, advertising them. So depends on where you are using it. Some of the small appliances, if you get a good solar generator, it is efficient. It will serve. Then for the biggest solar systems, you want to power your freezer, you want to power your air conditioners, you want to power more loads, ceiling fans, standing fans, I will advise you go for the normal conventional solar system, because even if there's an issue, you can easily trace to know whether it is from the controller, it is from the inverter, or it is from the solar panels. But the generator, everything is integrated. So if one thing is bad, most times you have to return it to the company. Mr. Sibusiso, please, if I wrongly pronounce your name, don't be offended. Seller would like to understand how to calculate the total load that is used in a household, and is it possible to go total off grid and only rely on solar power? All right, the first question, you asked two questions there. You want to understand how to calculate total load that are used in a household. There's what we call load audit or load analysis. Now, before you size a solar power system or before you install a solar power system, you need to carry out what we call load audit. The load audit is that you go to either the client's house or your own house that you want to use solar. You check all the appliances you want to use on solar. You want to use television, you want to use refrigerator, you want to use water pump, you want to use air condition, you want to use standing fan, ceiling fan, or any other electrical appliance. You need to look at what we call power rating. All electrical appliances are rated in watts. They are rated in power. They have what we call power. Power is voltage multiplied by current. So you need to know the power rating of those appliances. How can you know the power rating of an appliance? You know the power rating of appliance by looking at the nameplate or the specification sheet of that appliance. Look at the back of that appliance. There's always a label there's always a label on all electrical appliances. Let me bring something, an electric kettle, something I'll show you. Just excuse me. All right. So this is an electric jug. So if I want to know the power rating of this electric jug, I will go. If you look at behind this, this is the jug. Look at it. This is the jug. So behind, if you look at the back, there's a small label. I see the label there. It is small. You may not be able to read it. So there's a small label. That label will give you the specification of this kettle or this electric jug. So this one, the power rating of look at it, power consumption is 3000 watts. the power consumption of this kettle is 3000 watts, which means if I want to size an inverter for my solar system, I must size that inverter that will be able to power this 3000 watts electric kettle. So look at the back, we call it nameplate or specification sheet. You will see the power rating of that appliance or that load. Now you write it down. For television, you write number 1, power rating, you write, let's assume 50 watts. Then you also check the quantity. How many televisions are you going to use? Is it 5? Is it 2? Is it 3? Is it 1? You write the number. Now to get the total power of all those televisions, whether they are 5, 4, 3, 2, or 1, multiply. For example, you have 2 televisions and each of them, their power rating is 50 watts. So if you want to know their total power rating, you multiply 50 by 2 to give you 100 watts. It means those televisions will give you 100 watt. That is 50 plus 50. But if you have one television, let's say 56, you have one television, let's say it is a 42 inches television, and the power rating is, let's say, 60 watts. Then you have another television, 32 inches, and the power rating is 40 watts. How do you know their total power? You sum them up. That is 60 plus 40 will give you 100 watts. Now, to know the total energy consumption of those loads, you check how many hours you'll be using them per day. Multiply the total power by the runtime hours. That is the number of hours you'll be using them per day. It will give you their total daily energy consumption. But for the wattage, it starts from knowing the power rating. Power rating, that is the basic foundation in knowing how to size a solar power system. What is the power consumption of this appliance, of this load? This is where many people always fail, and that is why after installing the solar system, you'll be having issues because some loads in that house, they are drawing so much power from the battery bank, so the battery bank will not last. Some of them, their power rating is higher than the inverter, so anytime you switch them on, the inverter will shut down because the inverter cannot carry. So when you know the power rating of those loads, then you know the ones that have such power or starting power. You also take it into consideration. So to get detailed video, check my channel. You will see videos, most of my videos on how to size a solar power system. You see how to prepare a load analysis table. From there, you'll be able to get the total power, you get your total daily energy consumption. From the total daily energy consumption, you'll be able to size the battery bank, size the solar panels. From the total power, to size the inverter. So I don't know if Mr. Seller, if I've answered your question. Then you can go totally off grid if you want to. Off grid is that you are not having power from the grid. You are not, yes, there's no grid power, there's no grid supply. So you are totally off grid. So you are depending solely on the solar panels. So for you to go totally off grid, just like I said earlier, you must know the appliances you're using. You know their total daily energy consumption, how you're going to use them, because you're going off grid. Then you now size the solar panels, the batteries that will be able to sustain these loads, because you don't have the power from the grid that you say, oh, in the next 5 hours, I will have grid power. So the power will be able to sustain my load. So if there is no sun, you should know that the loads will depend solely on your battery bank. So you should have solar panels that will be able to generate enough energy to store in your battery bank during the day when the sun is available. Now, if you are using your appliances both in the day, during the day and the night, like most of the heavy appliances, the refrigerator and the air conditioners, you want to use them during the day, you must also know the number of solar panels you are going to size that will generate the energy during the day, that will power the refrigerator, power the air conditioner, and also charge your battery bank. So you can go totally off grid. Then Mr. Peter, my question, sir, is depth of discharge. Is there a particular settings for it on the inverter, or one has to be watching when it gets to its maximum DOD? Now, when we talk about depth of discharge, the depth of discharge is the amount or the percentage. The unit is in percentage. Now, it is the percentage of energy, the amount of energy you are going to take from that battery bank to use. So if your battery, we have what is called depth of discharge, DOD. We also have what is called state of charge, SOC. Now, they are opposite. If your battery bank DOD is 100%, it means your state of charge is 0%. If your state of charge is 100%, it means your depth of discharge is 0%. If your state of charge is 50%, your DOD is also 50%. If your state of charge is 70%, your DOD will be 30%. It means your battery is 70% full. You have taken 30% out of that battery bank. So the DOD is the amount of energy that you can take from a battery bank. So manufacturers will always give you a guideline. There's, if you buy high quality batteries, there's always a manual on those batteries. And the manual, there will be a graph. There's what we call duty circles. There's what we call circles, and the DO, that is the percentage of discharge, the DOD. So a battery will be having circles. The manufacturer will tell you the circle there is, when you charge a battery and you discharge a battery, you have completed one circle. So we take a circle to be like 1 day, because you charge the battery, you use it, you recharge the battery, and you drain it. So it is one circle. So a circle is like 1 day. So if you have a year, we have like 365 circles. So from these circles, if you're using 50%, if you're using 60%, you can calculate how long this battery will last. So the manufacturer from that graph will give you a guide that this battery, if you discharge it at 50%, this is the circles. Maybe at 50%, you may be having 500 circles. At 30% DOD, you'll be having like 800 circles. At 20% DOD, you may be having like 1,000 circles. At 80% DOD, you may be having like 300 or 200 circles. What that means is that the more you discharge a battery, if you discharge a battery bank, you are reducing the lifespan of the battery. If you deeply discharge it, you're reducing the lifespan of the battery. That is why, as a guide, it's not as if it is a standard rule that you must use. It's just a guide that for sealed batteries, you use 50% DOD. For flooded batteries, you use like 70% DOD. For lithium batteries, you use 80% DOD. It's a guide. That does not mean you cannot discharge that battery down to 100%. That does not mean you cannot completely discharge the battery. You can, but completely discharging a battery is not good for the health of the battery. That battery will go fast. You're killing the cells of that batteries, and it will not last for long. But if your DOD is high, the amount of energy you are taking from that battery will also be high, but the battery lifespan will be reduced. If your DOD is low, the amount of energy you are taking from the battery bank is low, but lifespan of the battery will be long. So it is not as if we have a standard rule that this battery you must use this. It depends. There are some people who need high amount of energy, and they will tell you, okay, if you calculate the number of cycles, if this battery will last me for 3 years, give me 80% DOD, give me 70% DOD. So in the next 2-3 years, I will change the battery. Or in the next 1 year, because they need high amount of energy. And for you to get high amount of energy, you increase the DOD. Now, this issue of DOD, you need to discuss it with your clients, because when you reduce the DOD, the size of the battery bank will be large. But if you use high DOD, the size of the battery bank will not be large. And if you are increasing the size of a battery bank, you should know that the cost of the solar system is increasing. So you need to discuss with your client. Now, In terms of setting, there's what we call low voltage disconnect, LVD, in an inverter. From that setting, you can control the DOD of your battery bank. So if you set your inverter that on the LVD to be, let's say it is a 12-volt battery bank, you check the manual of that inverter and you see the settings. You can set it that at 12 volts, the inverter should shut down. At 12 point something volts, there are control measures you can use so that you will not be bothering yourself to look at the controller. What is the state of charge of this battery bank? If it is going down, then you now maybe wake up in the night to come and switch it off. No, you can do the settings using your battery, your inverter or other battery management systems, DMS, to do that settings. And once it gets to that set voltage, low voltage disconnect, the inverter will shut down. Then Mr. Ni Adeyemi, I saw an EcoFloat solar generator of 1000 watts capacity. What can this power? 1000 watts capacity, you need to look at your loads. It means your load should not exceed 1000 watts. You can use, your loads can be up to 800 watts, now depending on, you look at the specifications, they will give you a guide. But it's not about the 1000 watts. What is the size, the capacity of the battery bank? Because if they say it's 1000 watts and probably you connect 500 watts load to that inverter, how long will it last? What is the size of the battery bank? When you know the wattage, yes, it is good. Go and look for the size of the battery bank. How many watts hour? If it is a lithium battery, how many kilowatts hour? How many watts hour? What is the capacity of the battery bank? That will tell you how the number of hours that system will last if you connect your 200 watts load, 300 watt loads, or 400 watt loads to the EcoFloat. So look at the size of the battery bank. Then Mr. Victor Akpan, a new tubular battery after fully charged, when the inverter is on without any load, it drops to 12.4 volts within 3 minutes. Is this normal? A new tubular battery after fully charged, when the inverter is on without any load. If you have a clamp meter, look for a clamp meter. Move that this again. Let me show you how a clamp meter looks like. There's what we call clamp meter. It will help you if you have it, though it's expensive. There are other cheap ones. No, the down drawer. Okay. This is a clamp meter. This one is Fluke. This is Fluke clamp meter. So if you want to know, you know that this is an inverter. Always connect these terminals to your battery bank. So you set this meter to read current. Now you clamp this terminal. From this terminal, if you set it on current, it will give you the amount of current that is coming out from the battery bank. So most times, the inverter may have issues, or there's yes, there may be an issue in the inverter, and that inverter will be taking. I've experienced such thing. Most times, at times, if you do a grid connection, if you connect that inverter to the grid to also charge, if you don't do the connection well, it will become like a load. And once you put on the inverter will be sensing a heavy load. It will be drawing a high amount of current from the battery bank. So use a clamp meter. It is this thing that will help you. It's very, very important in solar installation. You clamp and you see the amount of current that is leaving that battery bank. But if nothing is coming out of the battery bank, the amount of current is maybe 2 amps, 3 amps, and you have a fully charged battery and it's running down within 3 minutes, it means that battery is not okay. So check, you can replace it with another battery and test, you will see. But if you don't have a clamp meter, this is another way to check. If you don't have a clamp meter, use another battery and check. If it is still draining, you change it. Maybe use another inverter and check it, since you don't have a clamp meter. So if you don't have a clamp meter, it will stress you. But if you have a clamp meter, it will not stress you. Once you clamp one of these cables from the inverter to the battery bank, you will see what is coming out from the batteries, what the inverter is drawing from the battery, the amount of current the inverter is taking from the battery. So if the current is high, you should know that there's a problem, there's a fault on the inverter. So that is how you can solve that problem. Or you use another battery and check. But if you check and the inverter is okay, it's not dragging enough power, then you need to look at that battery. You said on a 130 watt load, it takes the fully charged tubular battery 4 hours to attain a DOD of 50%, 12.06. You said on a 130 watts load. Is it a 12 volts? How many batteries? Please let me know if it is a, okay, you said it's a 12 volts 220 tubular battery. So it's, in other words, it's a 12 volts battery bank. So if you have let's say you have 130 watts, 130 divided by 12, it's taking about 10 amps from the battery. Or if the battery is fully charged, 130 divided by, let's say, 12, it's taking about 10 amps from that battery. So if it is a 220 amps, if it is fully charged, let's even take 200 amps, because most of them, they are not up to that rated capacity. So let's take like 200 amps. 200 divided by 10. It's supposed to take that load 20 hours for that battery to be fully discharged. It's supposed to take it 20 hours. That is 200 amps hour divided by 10 amps that this thing is taking. So check the battery and also check the load. Check the battery and the inverter. The problem will be coming from one of them. So Mr. Charles, how do we apply C rates to size battery bank? How do we apply C rates? I will do a video on that. I'll prefer to use a board, a marker board, to do that explanation so that you understand. It's very important in sizing a battery bank, the C rating of a battery. You see C rate, temperature, there are a lot of things you need to take into consideration when sizing a battery. And also the manufacturer will always give you a guide in terms of the C rate and the rest. I will do a video on that. Thanks for the question. I will do a video on that, but I will use a marker board so that you will understand better. Mr. Seller, you said, thank you so much. I appreciate. Thanks. I'm grateful. Does overcharging affect the battery? Yes, overcharging affects a battery. If you're overcharging a battery, overcharging and over discharging of a battery is not good. You'll be destroying that battery. It's not good. It's not good. That is the essence of a solar charge controller, to control the charging of the battery. And that is why you also need to size your solar panels to stay within the limits of the battery, so that it will not give high current or high voltage to the battery that can destroy the battery. So overcharging and over discharging a battery is not good. Then how do we understand the capacity of the battery? For a battery of 500 watts hour or 500 amps hour, what is the implication? 500 watts hour and 500 amps hour. 500 amps hour at what volts? For you to get watts hour, you multiply this amps hour by what's it called? By the voltage of the battery. It will give you the watts hour. The watts hour there is telling you the energy that is stored in that battery. So if you have a 12 volt, you have a 12 volt, 200 amps hour battery. For you to know the energy that is stored in the battery, you multiply the 12 volt by the 200 amps hour. It will give you a watt hour or kilowatt hour. It will now tell you the amount of energy that is stored in the battery. So for example, from your question, you're having 500 watts hour. It means your daily energy consumption should not exceed 500 watts hour. If your daily energy consumption exceeds 500 watts hour, it means that battery will not be able to sustain you. It will shut down. So if your daily energy consumption exceeds 500 watts hour, it means you need a battery bank that will be able to supply that amount of energy. So we have watt hour, we have amps hour. For you to get watt hour, you multiply the amps hour by the voltage rating of the battery. You will get the watt hour. The watt hour is the energy stored. So please, Mr. Charles, he said, I have watched videos where inverter efficiency is not used in sizing battery bank. Is this normal? We have what is called inverter efficiency. Now, in sizing a battery bank, there are a lot of things you need to take into consideration. The reason is that a solar system is not like generator or power from the grid. It's not like that. You are bringing in different components. You join or combine these different components together to generate electricity. So when we talk about the inverter efficiency, look at the inverter. Like I earlier explained, this is the DC side of the inverter, and this is the AC side of the inverter. Now, this inverter takes DC and converts to AC. During the process of conversion, there are losses. So the efficiency of the inverter tells you how efficient, how well, how good this inverter will be able to, convert this DC to AC smoothly without much losses. So it depends on the inverter you are using. If the efficiency, most of the inverters, the manufacturer will tell you the efficiency. Some they will tell you it's 85%. The efficiency is 85%, 80%, 90%. But most modern inverters, the efficiency is almost 90%. That is why we are using at least an average of 90% in sizing. When you size your solar system, after taking all these things into consideration, it will be difficult for that system to fail. It will be difficult. So when sizing your system, because in converting DC to AC, it's taking that power from your battery bank. So you need to take that into consideration. Also, remember that this inverter also have what is called a standby power consumption. Even when loads are not connected to the inverter has its own standby. That conversion is making use of energy, is making use of power to do that conversion. And for all these LEDs, like other bigger inverters, the LED screen, all other battery management systems to function efficiently, they need the power from the battery. So they're also consuming. They have their own self-consumption. So you take all those things into consideration so that your system will not be giving you issues. Mr. Habib Giwa, greetings. What's your advice for a DIY 500 watts inverter installation? The panel, wiring, and battery. The advice is that you should know the total daily energy consumption of the loads. It doesn't end in knowing the power rating. Yes, you have the DIY system is 500 watts. It doesn't end there. What is the total daily energy consumption? For you to know the total daily energy consumption, multiply the watts by the number of hours you'll be using. So if you know the watt hour, that is the total daily energy consumption, that will guide you in sizing the panel. Then from the solar panel, you'll be able to size size the cable that you need to connect from the panel to the charge controller. Also, the size of the charge controller will guide you in sizing the cable from the charge controller to the battery bank. For example, if you're having if that happens if you're using MPPT. For the MPPT, from solar panel to charge controller, the cable is always small because you are using high voltage and low current. But from the charge controller to the battery, the cable size will be different because at that time the MPPT has converted that high voltage to enough power. So you'll be having high current that is going to the battery, high charging current. So you need to size the size of cable between the charge controller and the battery bank will be bigger or will be larger. So it is after knowing you have known your wattage, what is your total daily energy consumption? That will guide you in sizing all the components. This one, the total wattage, will guide you in sizing the inverter. But you need to size other components like you mentioned, the panel, the battery, the cables, the breakers, and others. So you need to know your total daily energy consumption multiplied by your runtime hours. When is the next live chat? It will be tomorrow by the grace of God. Mr. Amostic Boni, please, what should be the maximum current reading of battery while charging from inverter using power grid? What should be the maximum power reading or current reading of battery? That is dependent on the specification or size of battery you're using. And most inverters, from their settings, they will give you their maximum charging current. Then from the size of your battery bank, you should know the maximum charging current that this battery needs. So you set it from the inverter so that it will not exceed that maximum charging current. So for you to know the maximum charging current, you should know it from the size of your battery bank. What is the size of your battery bank? That will guide you in knowing the amount of current, the maximum amount of current you can send to that battery. And also, most battery manufacturers, like the high quality batteries manufacturer, they will always tell you the maximum and the minimum charging current of the battery. Mr. Boni, I have two of 200 amps hour, 12 volts. I use clamp meter, which I got 16 amps. 16 amps is okay. Two of 200 amps hour, 12 volts. Is it a 12 volt or 24 volt system? Let me know. Let me know. Wow, thanks for joining my live broadcast. You're not letting me know where you're watching from. Let me know where you're watching from so that I will know where my viewers are coming from. Where are you watching from? What time? I think it will be same time. I think we started around, is it 7? Yes, we started around 7 p.m. West African time because I'm in Nigeria. So 7 p.m. Nigerian time, which is West African time. Mr. Delamy, I really appreciate you. Your lecture is so helpful. Thanks. I'm also very grateful and thank you for also joining my live broadcast. Yes, I'm still waiting for more questions if you have. I'll still repeat because most persons join the live broadcast late. So this is a breaker. This is a breaker. You can see it. It's a breaker, on and off, on and off. So it is also a safety device that you connect to you install in your solar system. It's very, very important. It helps you when you want to disconnect a system or connect a system. You isolate. If you want to isolate the solar panels from the charge controller, it's just to break it. Isolate the battery from the charge controller, use a breaker to break. You want to isolate inverter from your battery bank, you use a breaker. Now, when you are connecting inverter to a fully charged battery bank, if there's no breaker, once you connect the first terminal and you want to connect, maybe you connect this terminal first or any of the terminal first, and you want to connect the next terminal, as you touch it on the terminal of the battery, you will see a spark. In fact, if that battery bank is large and the battery bank is fully charged, at times this ring, this cable lock, this connector will burn. You see it, it will burn, it will melt. Why? Because the battery is fully charged and you're connecting this inverter to it, you see a spark. So, but if you have a breaker that is connected between the battery bank, between the battery bank and the inverter, it's just to break. So when you connect, you will not experience that spark. You will not experience the spark, and your system will be smooth. It will not cause all those hazards. So you connect. You need a breaker between the solar panels and the charge controller. Between the charge controller and the battery bank, you need a breaker. Between the battery bank and the inverter, you also need a breaker. Between your loads and the inverter, that is the output side of the inverter, to your loads, your DB, your breaker, or your breaker, your distribution box. You need distribution box. You also need a breaker. But from the inverter output to your load, you need an AC breaker. We have AC breakers, we have DC breakers. So you must know where to make use of them. Don't carry an AC breaker and install between the solar panel and the charge controller, because that side is DC side. So you don't use an AC breaker where you are having DC. You don't use a DC breaker when you are having AC. So know where you are going to install them, and you should be able to differentiate between a DC breaker and AC breaker. There is always a sign. If you look at the breaker, there will always be a sign. You will see the DC sign there if it is a DC breaker, and you see the AC if it is an AC breaker. Now, breakers like this one, it is rated 100 amps. It is a 100 amps breaker, and the maximum voltage here is 250 volts. And this is a single pole breaker. It is single pole. It means you can only connect it to one of these terminals, this red terminal. You can only connect it, but the double pole breaker, you can connect these two terminals there. So always know the application. Is it DC or AC side? Where do I need this breaker? And if I need this breaker on the AC side, it means I need an AC breaker. If I need it on the DC side, it means I need a DC breaker. Then you also need to know the maximum amount of current that is flowing through, the maximum amount of current, the maximum continuous current that is flowing through if it is from the solar panels to the charge controller. Then you also need to look at the voltage so that the breaker will function efficiently. If you oversize a breaker, the breaker will not trip off when it is supposed to save the system. Then if you undersize it, it will be tripping off anyhow. Those ones that are very sensitive, it will be tripping off any little change in current, mostly during the day when the intensity of sun is fluctuating. The breaker will just be tripping off anyhow. So you need to know how to properly size it. Now, from the solar panels to the charge controller, if you want to size the breaker and you know your maximum amount of current, you multiply it by 1.56. It will give you the size of breaker that you need. From the inverter to your load side, from the battery bank to your inverter, you multiply by 1.25. But from the solar side, the solar panels to the charge controller, you multiply by 1.56. The other one, you multiply by 1.25. So for the solar panel, you are taking into consideration the maximum amount of current and the maximum continuous current that will be flowing through those cables. Then Mr. Sele, you're watching me from South Africa, where we suffer from load shedding. It's common in most of the African countries. Then Mr. Morris Thompson, if I send you Cash App, can you send me PDF for training? Yes, you can. I think you were the one that asked if you. I don't think I will check. It's like you have made payment for that thing. I will check because my live broadcast, I think I saw a payment. Okay, I will check and forward that document to you, Mr. Morris Thompson. You were the person that you sent me a super last time, I believe so. So I forgot, sorry. I was supposed to send a PDF. I will do that after this live broadcast. So what I just need is your WhatsApp number. Send me your WhatsApp number and I will drop it there. I will send it to you. Mr. Phoenix Electro Center, is it good to charge 100% battery of lithium ion battery? Charge it 100%. Yes, all batteries are supposed to be 100% fully charged. If you use your battery till the next day, once the sun is coming up, it is expected that before the end of the day, the battery should be 100% fully charged. It means you have completed the cycle. So if you discharge the next day when you're charging the battery, you're recharging the battery, it should be 100% fully charged. It will help in increasing the lifespan of that battery. The battery will last longer. So Mr. Abu Asma Ahmed, true sir, you should tell us time of live stream. I'm watching from +254. +254 is what country? I said I'll be coming live by 7 p.m. West African time. I think it's +1. That's our time difference. It's +1. So West African time. I'm in Nigeria. So I'll be coming on live by 7 p.m. West African time. Mr. Mapuranga, how much PDF for a solar installation guide? Is 3,000 Nigerian naira, and I think it's $2.5. So there's a WhatsApp link on my channel description. Just click on my channel description. You see my WhatsApp link. Click it. You can reach me on WhatsApp and we'll communicate from there. Mr. Charles, when you mention maximum current, do you mean yes? Do you mean ISC or IMP? It's ISC. The maximum current I'm talking about is the ISC. That is a short circuit current. Telling you the maximum amount of current that solar panel can produce when the impedance is high, is even up to 1,000 watts per. So when you're sizing breakers, you're making use of short circuit current, not the maximum power current. You're making use of short circuit current. So thanks very much for joining my live broadcast. He mentioned this short circuit current, an IMP. Always know how to interpret the parameters, the specifications you're seeing written on your solar components. Whether it's solar panel, like the solar panel, you see maximum power, Pmax. You see maximum power voltage, VMP. You see maximum power current, IMP. You see short circuit current, ISC. You see open circuit voltage, VOC. You also see maximum series fuse rating. All these parameters are written there to guide you. You need them as a professional solar installer. They'll be able to guide you in efficiently sizing your solar power system. Then when you go to the charge controller, you see the current, the maximum current, you see the maximum DC, the maximum PV input voltage. You see there, they will tell you the maximum VOC, open circuit voltage you should send to that charge controller. The maximum power voltage you should send to that charge controller. The battery bank is the same thing. The inverter, if it is a hybrid inverter, they will give you specifications you need to connect solar panels to the inbuilt charge controller, whether it is MPPT or PWM. Then they will give you the parameters if you want to connect it to the grid, the minimum grid AC voltage you can connect, and the maximum you can connect. All these things are very important. They will give you a guide. Hi, Mr. Morris, I've seen your message. I will respond when I'm through. They will give you a proper guide. So when you make use of all these parameters, they will help you in properly sizing the solar system. So always do well to look at specifications. The specifications there are what is written on the manual. For example, let me show you. This is a manual. This is a manual for a 3 kVA hybrid inverter, Felicity inverter. This is the manual. If you go through it, you will see a table for specifications. You will see also codes, fault codes. If the inverter is having faults, what you should do. Look at this table. It's very, very important. If you see something like this, this is where you have all the guide. With this, you can install the inverter. Because if you live inside this manual, they also gave there's the recommended size of cable you should use for to connect between the inverter and the battery bank. Then from the solar panels to the inverter, because it's a hybrid inverter, the maximum cable you should use, the size of cable. So everything is written here. This manual is the mind of the manufacturer. He's telling you that this is my device. For you to use this device to serve you very well, this is what you should do. So for the fact that you know how to install, let's say, a grow watt 3 kilowatt inverter, does not mean if you have a Felicity or Victron inverter, you should not read the manual because you already know how to install an inverter. No, read the manual. Their configuration may be different. Their settings may be different. Everything inside may be different. So that is why you need to look at the manual. Read the manual. It is very important. as an installer, before you install any component, always read the manual. Another reason is that if you look at the manual, the manufacturer will always tell you that they can change the design, they can change the components inside without your notice. They don't need to notify you. So it is only through the manual that the manufacturer will tell you that the one you know, the last time, the last device you use, the last model you use, we have upgraded it. So you need, this is what you need to do for this current one. So it is important you go through the manual. It will help you, it will guide you, and also save you. Because if you don't go through the manual, most times you end up destroying the inverter, you end up destroying your battery, you end up destroying the charge controller, and you end up not being able to harness the maximum amount of power your solar panel can generate during the day. So it's very important. Mr. Mostik Boni, what is the question again? You said you asked a question which you were unable to hear my answer. I can't remember the question. No? Okay, Mr. Morris Thompson, I received your text. I will respond at the end of this broadcast. Mr. Phoenix Electro, thank you so much, sir, for the great answers. I am watching from Uganda. Thanks very, very much. Let me, Mr. Mostik Boni, what is the question? Okay. You said you have two of 200 amps hour 12 volt. You use clamp meter, which you got 16 amps. So what you are asking is what should be the maximum current reading of battery while charging from inverter using power from the grid. And I told you, what I answered is that look at the inverter. The inverter manufacturer will always tell you the maximum amount of current. So it is from there you set. But also your battery bank. Look, that is, I just finished talking about specifications. Look at the specifications of your battery. What is the recommended charging current, minimum and maximum charging current of the battery? Look at it. It will guide you so that you'll be able to impute the setting on the inverter, the maximum charging current. It makes you to stay safe. Most times, I don't like giving you an answer because I don't know the model or the product of the component you're using. So always go to the manufacturer's manual. It is the mind of the manufacturer. When you see those specifications, you do your settings to fall in line with the recommendations of the manufacturer. Mr. Ahmed, sir, now I become a good expert in solar installations. Thank you, sir. God bless you for your efforts. My question, how will I know the everyday my DOD? The DOD is what you are taking from the battery bank. If your inverter have what we call state of charge, from your state of charge, SOC, you know your DOD. I told you that the DOD is the opposite of state of charge, SOC. Most inverters have it. So if your state of charge is 60%, it means your DOD is 40%. If your state of charge is 80%, your DOD, what you have taken from the battery is 20%. The DOD is the amount of energy you have taken from the battery. But if you have a 12 volt battery, it is recommended you don't discharge that battery below 12 volts. It's not too good. In fact, it's good you stay around 12.2, 12.3. Going below 12.0, some even discharge down to 11.5 is not good. You're mostly for sealed batteries. It's not too good for them. You're destroying their cells. No, I will not forget. I will do a video on that. I need advice on, is it 10 or 10,000 watts on a 700 watt solar panels? How batteries I need? You are having a 10,000 watts load and you need 700 watts in a solar panel, and your this thing is Mr. Morris Thompson. Thank you again for your gift. I'm very grateful. Thanks for the super thanks. We have what is called super thanks on YouTube. You use it to support your favorite creator or the channel you're supporting. So this is what Mr. Morris Thompson has done. Thanks very much for the super thanks. You say thanks for all you do, sir. I'm very grateful and appreciate. I appreciate. Thanks very, very much for the super thanks. And others, you can also join to send the super thanks. It's on YouTube. You see the button there. You click it. You can use it to support, support my work, support me, and the teaching is a way of supporting, a channel, your favorite channel that you're watching. So thank you once again, Mr. Thompson. I will chat you up on WhatsApp once I'm through. Thanks. I'm very, very grateful. So you were saying 10,000 watts load and you need a 700 watt solar panels. How many batteries I need, and I'm connecting it on a water pump? What is the size of the water pump? How many horsepower is the water pump? Then the water pump, is it a DC water pump or AC water pump? There are different things you need to look at. So I cannot give you a straightforward answer. Is it a DC water pump or an AC water pump? Then what is the capacity? What is the size of the water pump? That is the power rating. Most in short, water pumps are rated in horsepower, majority of them. So what is the horsepower? From there, we'll be able to know the wattage. Or some of them are rated in kilowatts. You see 0.75 kilowatts, you see 0.5 kilowatts. If you convert to watts, you can convert to watts by, I think, you multiply by 1000 to give you watts. Then if you need kilowatts, you divide by 1000. So I need the specifications of the water pump to properly guide you. Thank you very much, Mr. Thompson. Okay, Mr. Charles, you're thanking him for me. I'm grateful. Okay, you said it's a DC water pump and it is 240 volts. So how many watts? What is the wattage of the water pump? Please let me know before, so that I will attend to this one last before I go off. It is 240 volts. From this 240 volts, you can know the maximum amount of panels you can send to it. I mean, voltage. So let me know the wattage. It is from the wattage that I will know. So if your VOC, that is the open circuit voltage of your solar panel, is, for example, the open circuit voltage of your solar panel is, let's say, 36 volts. So you can connect those solar panels in series. So you are having 240 divided by 36. So you can connect 6 of those panels. It's giving 6.6, but you don't need to exceed this 240 volts. So you can use 6 panels or 5 panels. You connect them in series so that you will not exceed this voltage of 240 volt. I believe it is 240 volt DC, because the manufacturer will always indicate it there, whether it is DC or AC. So you said it's a DC pump. So I believe this is 240 volts DC. So if you divide it by the open circuit voltage of your solar panel, it will give you the amount of solar panels you can connect in series to that water pump. But the next thing is for us to know the wattage of that water pump. Is it a 1 horsepower water pump? Is it 1 kilowatt? Is it 0.75 kilowatt? Is it 1.2 kilowatt? What is the size of the water pump? Then we will now know the number of solar panels we are going to use, the size of the solar panels. Mr. Hamza says, I have 4 12-volt 200 amps hour batteries. At how many amps should I charge them? 4 of them. I have 4 12-volt batteries. Are there, what is the battery bank, this thing? Is it is it 24 volts or what's it called, 48 volts or 12 volts? But most manufacturers will tell you that the charging current should be like 20% of its rated capacity. Some will say, I've seen one that is up to 30% of its rated capacity. So if you have 12 or 200 amps, 200 multiplied, let's use 20%. So the maximum current you can use on the battery is 40 amps. Is it, sorry, 20 multiplied by 200 is 40 amps. You can use 40 amps. That's the maximum charging current. But some, they will tell you that the maximum should be 10% of the battery capacity. So if it is 10%, it will be 20 amps. The maximum maximum charging current will be 20 amps. Some will tell you it is 15%. So look at the manufacturer's manual. So, Mr. George, do you offer classes to become solar engineers? If so, where it is an online class, you can join. Send me a link. I will give you the details. Check my my YouTube channel. You'll see my WhatsApp link. Mr. Yahaya, I'm waiting. What is the how many watts? What is the wattage? Let's assume it is a 1000 water pump. The power rating of the water pump is 1000 watts. If it is 1000 watts, it means the maximum because it is a DC pump. So how many watts of solar panels will I use? So let's assume it's a 1000 watts pump, and we are taking into consideration the performance ratio 1000 multiply 0.65. Divide by 0.65. 1000 divide 0.65 will give us 1538. Then let's assume we are using 300 watt solar panels. This will be divided by 300. It means we need 5 pieces of 300 watts panel. But mind you, most of these solar pumps, or most of these, or in fact all the water pumps, if you look at their data sheets, you'll see a graph that is plotted. I think power against volume, either power against, it should be power. That's the power from the solar panels against volume. So if you give the solar panel, if you give that water pump maybe 500 watts, the manufacturer will tell you the amount of the volume of water that water pump will pump at 500 watts. If you give it 200 watts, the manufacturer will tell you from that data sheet that if you supply 200 watts to this water pump, it will be able to pump maybe 100 liters of water per minute. If you supply 500 watts, it will be able to pump 200 liters of water per minute. If you give it complete 1000 watts, it will be able to supply maybe 800 or 700 liters of water per minute, liters of water per minute. So check the data sheets of that water pump. There's the pumps always come with their manual, and there's a data sheet inside. You'll see it should be power against voltage. There's a graph. So that graph will guide you in if you don't need high volume of water, you can use 200 watts, 300 watts, depending on the size. But you have to take into consideration performance ratio. You should know that the intensity of sun is not steady, it's not constant, it fluctuates. So you need to factor in the performance ratio of the solar panels. Mr. Hamza, you're asking how many solar panels. I've answered this question before. For you to know the number of solar panels, okay, you already have 4 12 volts 200 amps hour batteries with 48 volt battery bank. So for you to know if you already have a battery bank which is 200 amps hour 48 volt battery banks, the next step is for you to know the what's it called, the watt hour, that is the energy that is stored in that battery bank. So if it is 200 amps hour battery at 48 volts, the energy stored in this battery bank is 9600 watts hour. This is like equivalent or close to a 10 kilowatts hour lithium battery. So you can buy a single 10 kilowatt hour lithium battery. It's the same as this battery bank that you're having. 48 volts multiplied by 200 amps hour will give you 9600 watts hour. So this is the energy that is stored in this battery bank. So for you to know the number of solar panels you need to charge this battery bank, you need to know whether it is a sealed battery, it is a flooded battery, or it is a lithium battery. For lithium battery, you already know it's a 10 kilowatt. So let's assume it is a sealed battery. So if it is a sealed battery, you need to take into consideration the depth of discharge of the battery bank. For sealed batteries, the recommended depth of discharge is not as if you cannot discharge the battery bank up to 100. You cannot completely discharge the battery bank, but this recommendation is that for you to keep that battery safe so that the battery lifespan will be longer. But if your daily energy usage, the amount of energy you're using is high, you can increase your depth of discharge, but you know that the batteries will not last long. So for this one, let's say we are using 60% DOD. So if we are using 60% DOD, the next thing for us to do, for us to know the amount of solar panels we need, we will divide this by we will multiply this, sorry, not divide, we will multiply this by 0.6, which is 60%. You will multiply because you already have the energy. So we want to know the number of solar panels we need. So multiply the 9,600 by the DOD of the battery bank, which is 0.6. So at 60% DOD, what you can use from this battery bank is 5,760 watts hour at 60% DOD. So it is 5,760 watts hour. So this divide by our performance ratio of 0.65. Divide this by the performance ratio 0.65. This will give us 8,861 watts hour. The next thing is that we are dividing this by the peak sun hours. What is the peak sun hours in your location? Is it 3 hours, 4 hours, 5 hours, 6 hours, 7 hours, or 8 hours? So let's take 5 hours. So if we divide this by the peak sun hours of 5, we'll be having 1,772. So let's assume we are using Jinko solar panel rated at 440 watts. How many pieces of them do we need? So 1,772 divided by 440. We need 4. We need 4 pieces of 440 watt solar panels if you are discharging this battery at 60% DOD. If you want to discharge at 70% DOD, you multiply 9,600 by 0.7. If you want to use 75, it will be 9,600 multiplied by 0.75. Then from there, you divide by the performance ratio, you divide by the peak sun hours, you divide by the size, the wattage, the power rating of the solar panel. From there, you have the number of solar panels that you need. What breakers? You need to know the amount of current, like I said earlier, the amount of current that is flowing through the conductor. That is what will guide you in choosing the size of what's it called? The size of breaker that you need. Then Mr. Furon Sheikh Azar. What about the loss of the battery? Loss of battery. Probably you're talking about the effect of temperature, the inverter efficiency and other things. You take those into consideration when you are designing the size of the battery bank. He has already given us the size of the battery bank he's having. So it's just to check the number of solar panels he needs to charge that battery bank. But when you're sizing a battery bank from your total loads, you need to take into consideration, temperature, because during charging and discharging, there are losses. So you need to take those losses into consideration. There's heat. Increase in heat affects your battery. A high temperature affects the performance of your battery. Low temperature also affects the performance of your battery. These are things you need to take into consideration. So thanks very much Mr. Linus, you're talking about flow charge, bulk charge. Bulk charging is when the battery is low and the charge controller is charging that battery or the inverter. It needs high power to charge that battery fast. That's bulk. It's taking high, making use of the available energy that is there. Bulk charge to charge it and take it to fully charge. That flow charge is to maintain the voltage. If the battery is fully charged, so it will, that flow chart maintain that voltage at maybe 13.5 volts, 13.0 volts, so that the battery will not drop until there's no sun again or there's no charging source again. That's when the batteries now will start dropping, when you're using loads. But if the load you are using exceeds the charging capacity of your charging source, whether from the grid, the generator, or from the solar, that flow charge will not be maintained. It will be reducing. But if the charging is higher than what you're consuming, then once it is fully charged, it will maintain it. Then what you are using to power your loads will come from that charging source, will now be supplying that power to the loads. So it will not be coming from your battery. So power will only come from your battery when that charging source have stopped charging. So the battery will now start supplying. The inverter will now take power from the battery bank to power your loads. Yes, I do give courses. So check my channel description. You see my WhatsApp link. So thanks once again for joining my live broadcast. I'm very, very grateful. Thanks very much for your audience. I'll be live again tomorrow by 7 p.m. West Africa time. So please, those who have not been able to answer your question, join me tomorrow so that we will continue from there. Is it good to add an inverter and solar panels? Yes, you can have one earthing source. You add all your systems to that to the this thing earthing system. All your components need to be earthed, so you can connect all your earth cable from panel, the inverter, every other components, then from your such protective devices, SPDs, to the earth source. All right, you have downloaded the PDF. Thanks very much for downloading. Thanks for joining my live broadcast. I appreciate you all. See you tomorrow in my next live stream. Please don't forget, it's 7 p.m. West African time. Thank you very much. God bless you. Thanks. See you in my next broadcast. If you have other challenges, just go to my channel. You see different videos, different topics I've been able to cover. I'll still be uploading different videos, but the ones I have now, if you have questions, you can just, questions that are bothering you, go to those videos. If you watch those videos, some of your questions, most of your questions will be answered. So thank you. You have a lovely night rest and a lovely day. Thanks for joining. God bless you.